MS Ramaya University of Applied Sciences.
Hello students, let us discuss about forging. Forging is a deformation processing of materials through compressive stress. It is carried out either hot or cold. Hot forging is done at temperatures above recrystallization temperatures, typically 0.6 Tm or above, where Tm is melting temperature. Warm forging is done in the temperature range 0.3 Tm to 0.5 Tm. Cold forging has advantages such as good surface finish, high strength and greater accuracy. Hot forging requires lower loads because flow stress gets reduced at higher temperatures. Applications of forging. Typical applications of forging include bolts, discs, gears, turbine blades, crankshaft, connecting rod, valve bodies, small components for hydraulic circuits, etc. Effect of forging on microstructure. The formation of a grain structure in forged parts is elongated in the direction of the deformation. The metal flow during forging provides fibrous microstructure revealed by etching. This structure gives better mechanical properties. The workpiece often undergo recrystallization, therefore provide finer grains compared to the casting. Forging temperatures. Forging materials must be heated to a temperature at which it will possess high plastic properties both at the beginning and at the end of the forging process. If the forging operation is finished at lower temperature, this leads to cold hardening and cracks. With excessive heating, the forging suffer oxidization and much metal is wasted. Approximate temperatures for forging the following common metals at the beginning and at the end of forging process: upsetting or jumping. Upsetting is a process through which the cross-section of a metal piece is increased with a corresponding reduction in its length. When a metal is sufficiently heated so that it acquires the plastic stage, it becomes soft. If some pressure is applied to it, the metal tends to increase in its dimensions at right angles to the direction of application of force, with the corresponding reduction in its dimensions parallel to the line of action of the said force. The particular part in the bar shape where said increase in the cross-section is desired is heated till it acquires a fully plastic state. The hot portion of the bar is then kept on the anvil face and the bar hammered at the top, drawing out. This process is also known as drawing down. It is exactly a reverse process to that of upsetting in the sense it is employed when a reduction in thickness, width or both of a bar is desired with a corresponding increase in its length. The desired effect is possible to be obtained by the use of cross-peen hammer, a set of fullers. The process of heating and cooling the length not required to be drawn is the same as in case of upsetting, but the selection of the above tools is governed by the shape of the cross-section of the stock, the amount by which the increase in length is desired, and also the required finished shape of the job. Swagging. Swagging is a forging process in which the dimensions of an item are altered using dies into which the item is forced. Swagging is usually a cold working process. However, it is sometimes done as a hot working process. Swagging is a special type of forging in which metal is formed by a succession of rapid hammer blows. Swagging provides a reduced round cross-section suitable for tapping, threading, upsetting or other subsequent forming and machining operations. Anvil. It is made of solid wrought iron or cast steel. It is a support for the hot metal pieces to be forged. Tools like swags or fillers are inserted into the holes. Horn of the anvil is used for bending. Forging operations are carried out on the face of the anvil. Tongs. Tongs are used for gripping and turning hot metal workpieces during forging. Forge hammers. Hammers are used by smith for striking and to give required shape to hot metal workpieces. Hand hammer, small and light components. Ball peen hand hammer, general working and riveting. Cross peen hammer, stretching, bending. Straight peen hammer, it is used for stretching the metal. Sledgehammer, used for flattening. Grain flow in forging. Grain flow is a directional orientation of metal grains and any inclusions that have been deformed by forging. Individual grains are elongated in the direction of the metal flow or plastic deformation. More importantly, non-metallic inclusions, particles and other imperfections inherited from the casting process are elongated in the direction of grain flow. Forging grain flow boosts fatigue life. Greatly improved fatigue life and impact strength in aerospace, automotive and other industrial applications along with higher strength in thinner sections which directly results in lighter parts are the reasons why emphasis is placed on optimizing grain flow in forged components. Orienting the grain structure can enhance mechanical properties, boosting service life several times. This provides one of the intrinsic benefits of forgings.
Hi students, let us work on forging. In order to carry out forging, we have got gas heating furnace where the gas from the supply enters here, passes through the regulator and to the burner where it is ignited and enters the heating chamber where inside it has got a refractory lining and then the gases will escape through the chimney and this gas heating furnace can be heated up to 1000 degrees centigrade. This is the control panel. Where we can set the gas heating furnace up to 1000 degrees centigrade. Present it is 247 and then it raises up to 1000 degrees centigrade. Anvil, this is the anvil where the heated sample is placed on it and it is hammered with the help of tongs, flattener and sledgehammer. Round end tong, flat end tong, these are tongs which helps us to hold the heated samples during forging and this one has got a round end and this one is flat end, round tong and flat tong. Flattener, this is the flattener used to flatten the heated samples. Goggles, safety for eyes. Leather hand gloves which is to be worn during forging for safety and this is goggle which protects our eyes during forging. 8-pound sledgehammer used during forging. Raw material, this is the raw material used for forging which is a low carbon steel having 16 mm dia and 100 mm length. Let us start the experiment. First we'll have the power button switch on. We'll switch on the gas heating furnace, and the set value is 1000 degrees centigrade, and the process value at present it is 234 degrees centigrade, which will reach 1000 degrees centigrade and heat the samples. I am taking the round tongue, which will help us to hold the sample, and then carefully the sample has to be placed inside the furnace. And the door has to be closed. And wait until the temperature reaches to 1000 degrees centigrade. Now you can see that temperature has reached 857, which is above the recrystallization temperature for a low carbon steel, that is sufficient for hot forging. Now the sample is red heat. It is advised to remove the scalings before hammering, and the flattener is placed correctly. First, as we witnessed the forging process, could see that the round rod 16 mm dia and 100 mm length at room temperature, which was heated in gas heating furnace to 850 degrees centigrade, and then hammered to the shape of L shape and a taper. And this what you witnessed the forging. This completes the experiment of forging.
At MSR UAS, we spark your imagination unlike any other.